everyone, and welcome to Chip Talks. I'm really excited to start these podcasts and begin to tell you guys a lot of the things that I've learned over the years. We're going to talk about the endocannabinoid system. We might talk about philosophy. We might talk a lot about a lot of things on this podcast, but it will all center around human health and really, probably what you want to hear about human health. We're going to tell some truths. We're going to speak some truths. We're gonna dissolve some paradigms, we hope. We're going to lay down some groundwork here in this first podcast that's going to be very important. So you might be coming to this podcast from 5 years in the future, where I've referenced it in some other podcast. I've said, go back and listen to podcast number 1 of Chip Talks, where we lay down the basis and the groundwork. So if you're coming out to us from the future, hopefully this is all widely known information by now. That would be the hope. If you're here in the present, what we're going to do is we're going to talk through a new model of human function. We're going to talk about how you work in a little bit different way. Now, if you're watching this via video, I apologize for my close-upness here, but I'm going to walk you through some slides, but I'm going to do my best. So if you're out there in podcast land, I'm definitely going to describe what we're looking at on these slides. If you want to know who I am, there's lots of information about me out there on the internet. Feel free to dig around. If you have questions, absolutely hit us up at info@newpharma. You can hit me up at chip@newpharma.com. Always here to answer questions. We're really here to help. You'll find that as these podcasts develop. And we've got some really exciting podcasts that will be coming up. We'll have guests on here. One of the things that we're talking about that we want to do in the first series of podcasts, we need to lay down some science first so that you guys have a basis really for a discussion about how you work. But once we lay down that basis, and that's why we'll be referring back to this one a lot, we'll be talking about a lot of human health issues, and we'll be talking about those in the context of really how you can heal yourself, what natural products exist, what tools has God given us here on this great earth that exist out there in nature that we can use to be able to heal our bodies. And certainly that is the way that I view the world, is that God has given us these great gifts in nature. We just need the knowledge really to unlock them and be able to use them. Okay? So one of the first things we're going to talk about is breast implant disease, toxicology, however you want to talk about it. But this is something that is affecting millions and millions of women, and it is quite severe. So we'll talk about that down the road, but we need to lay some basis first for discussion. So let's dive right into, I call this my model of human function. You can call this the new pharma, model of human function. You can call this whatever you want, but hopefully you will listen to this. Now, everything that I'm going to tell you here is research back. And what I mean by that is you can go out, and the best place to look really for bench studies here in the United States is our National Institute of Health. So you can go to nih.gov and you can dig around and you can, basically uncover the same information that I have over the last 10 years and a lot of work, or you can substantiate basically what I'm saying. So anything that I tell you, again, if I get off the reservation into bro science or and that's where a lot of people live in the cannabis world actually, I'll tell you that I'm off the reservation. I'll tell you when we're in theory versus hard research. But this should blow you away. I mean, this is going to be new information to you guys. So let's dive right in. First of all, we need to lay some groundwork, right? So perhaps, and I've got a quote up, so I'll just kind of describe to you guys listening as to what I've got up here on the YouTube. But I've got a quote up, and it's just a quote from me. But the slide says, let's say some groundwork. Let's say lay, not say, I will say some groundwork, but let's lay it too. And I have a quote, so I like quotes. But I say, perhaps what we were taught in high school anatomy is a bit dated and not quite correct. We work in a logical and elegant fashion that has been obscured in teachings to be overcomplicated and frankly just wrong. So right now you're thinking, what is Chip talking about? Well, we'll get into that. Okay, so if I ask you, how do you work? How do you work out there, listener? How do you work? You're going to give me probably an intelligent answer, but it's going to be confused and chaotic. If you go ask anyone how you work, again, you'll get a different answer from everyone, which is interesting. And no one can really very cogently or logically describe how you work. Now, I find that fascinating. Is it because we're gibbering idiots and we're not capable of understanding the vast complication of the human vehicle? No, not at all. Again, every day we deal with complicated machinery and, we're able to explain and do all kinds of stuff. If I ask you how your car worked, you're going to give me a very logical and cogent answer about how your car works. It's going to be structured. It's going to talk about the engine. It's going to talk about the fuel. It's going to talk about you drive it with a steering wheel. And guess what? Your answer is going to be pretty close to mine. Is going to be pretty close to your neighbors. Is going to be pretty close to anyone that you ask. So, why is there so much confusion around how we work? Let's offer that for your consideration. Chaos and confusion are the tools of whom? Order, logic are the tools of whom? Okay, so there you go. So let's get into it. Let's begin to look at you and describe you, kind of like how a vehicle would be described. So let's start with our engine, right? So do we have an engine? Is it an organ? Is it a special thing? Is it something that we've never been taught about? Is it some magical, mystical new thing? No, it's not. It's a little bit, interesting because we don't just have one engine. We've got a jajillion of them. And literally inside of every nucleated cell in your body, there are little guys called mitochondria. And it turns out that mitochondria are our engine. All of these little, thousands of them in each cell and thousands and millions of cells provide energy. And this is our engine, right? So this is literally the core of our being. Mitochondria are our engine. Now, arguably, if I ask you where you hold intelligence or where you hold consciousness, or, where God would touch us, if there was a way for God to touch us. Well, the answer is likely going to be these guys. And let me walk you through that. So let's say you say, oh, well, my, consciousness I hold in my brain and my intelligence I hold in my brain. Okay, well, what's a brain? Well, a brain is a collection of cells. Those cells are called astrocytes. And an astrocyte only knows it's supposed to be an astrocyte by the mitochondrial DNA inside of it. So the mitochondria determine cell health. They can determine a cell's fate. They, are the heart, if you will, of that cell. So if you look at where we hold intelligence or consciousness, and certainly what is our engine, mitochondria are likely. I make a very, sounds very arrogant. It's not to me because I know it's true. And honestly, it's not a great thing to have. It's a crushing weight and responsibility. But I claim to hold something called the Philosopher's Stone. And I make that claim because of mitochondria. And the mitochondria are the Philosopher's Stone. So knowledge about mitochondria, unlocks secrets to free energy, unlocks lots of big secrets, including how you work and the future of human health. So studying these guys, understanding how these guys work, and then optimizing these guys are super duper important. And guess what? You can do that with nature. You can do that with, herbs and plants and things that we normally find in nature, dietary fats in particular. Isn't that cool though? Isn't that neat? So if you look at what our engine is, it's mitochondria. And again, arguably, they're where we hold our intelligence, our consciousness, they're everything. So optimizing these guys is super duper 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 important. Hopefully you guys agree with me, because we want to, so if you're driving a car with a poopy engine, it's gonna, you're gonna have problems, right? It's gonna be susceptible to breaking down. It's gonna be susceptible to a lot of things. If you're driving that Ferrari with a Wingo engine, you're not going to be as susceptible to being sick. If you do get sick, you're going to run through it really quick. You're just not going to have the immune issues that we seem to have today. And really, why do we have these immune issues? It's because we do not understand how we work. But it's so easy to teach you. It's almost like to teach you the truth would threaten a business model. Oh, we can't say that, can we? And that's exactly true. To teach you the truth destroys this institution called pharma and medicine, right? So you don't need it anymore. You can find your cures in nature. So let's talk a little bit more about mitochondria. So let's talk about our gas. So what do, that's pretty important, right? So if we want to run our engines efficiently, we need to understand what our gas is. And it's really cool how these guys work. So humans, we kind of have to have, let's say, water things and oil-based things inside of us. And why do we need that? Well, fat-based things or oil-based things are how we signal, how we run our neurology. A lot of, let's say, chemical mediators are broken down from dietary fats. And that's what we use to run our bodies, frankly. But there's more to it than that, because we also have to move ions around. So if you look at how these mitochondria are fueled, it's ionic. So you have to be able to move ions around. You can't do that in fat. Fat is not electric. Fat you can't move ions through very readily. But certainly you can through water. So your body is kind of this water thing and this fat thing. And both of those things are super duper important to our human function. And guess what? Mitochondria, as an engine, will take two different fuel substrates, which is really cool. So they'll take a water-based substrate. They'll actually take three. We'll talk about the third real quick because we'll get it out of the way. A eukaryotic cell, again, and that's what we're composed of for the most part, but they also compose a plant. And mitochondria will certainly run on light as a substrate, and that is absolutely the most efficient way to run a mitochondria. But that is something called photosynthesis. Do you photosynthesize? Yes, you do. That's outside of most people's Overton window right now. So we're really not going to talk about that a lot in depth. We'll certainly talk about that later. There's a lot there, and a lot there that has to do with human health. But if you read about vitamin D and things like that, you'll understand that indeed we do have interaction with the sun, and we do photosynthesize, and vitamin D is a byproduct of that photosynthesis. But anyway, we won't talk about that for right now. That's a little bit outside of people's believability window, let's say. So we'll stick to water and fats as substrates for fuel for a mitochondria. But just keep in mind, we do have this light substrate that is the most efficient. So water is our least efficient substrate to be able to fuel a mitochondria. And we generally fuel mitochondria. The water substrate that we use is something called glucose. There's another one that's more efficient that we'll talk about later called ketones. And ketones are water-soluble fat, so it's sort of this water fuel from fat, which is going to be better. But our body will default to glucose. Our body will always run, we can always run our cellular structures on glucose. So mitochondria have a glucose, switch, if you will, a sugar switch. And that is the least efficient way to run a mitochondria. So 1 unit of glucose will convert directly to 2 units of ATP, which ends up being kind of the gas function. That is the least efficient way to run a mitochondria. The mid-efficient way to run a mitochondria is off dietary fats. So you have an oil-based substrate. Those are dietary fats to be able to run your mitochondria. Now, that's far, far more efficient than glucose. You will produce, from 1 unit of dietary fats, you'll produce about 136 molecules, and it kind of depends on stuff, but up to 136 molecules, sometimes even more, of ATP. So you're 50 is a good number. So you're 50 times more efficient. You're 50 times more energetic. You're 50 times more conscious if you want to go there. You're 50 times more intelligent if you want to go there when you're running your mitochondria on dietary fats rather than glucose. So I like to make the analogy that, kind of when you're running on glucose or this water substrate, that you're a plant in the dark with no water. So we're alive, but we're super subject to disease. We're kind of rotting, right? So we don't even realize it. So in the middle switch, we're out in the sun and we're thriving more. Okay, so hopefully everybody's got that concept. But again, so 3 different substrates to run mitochondria: water-based substrate, which we generally think of as glucose; a fat-based or oil-based substrate, which are dietary fats; and then a light substrate, which is photosynthesis. Okay. Again, if you're YouTube with me, you just saw another slide change. If you're listening at home, I'll kind of describe this slide. So what we've got up is really a look at how disease happens. And again, what is disease? Well, a disease is caused by pathogens. This is a plant slide, by the way, if you are YouTubing, but it makes the point. So being in the dark is not so good if you're a plant or a human. But where does disease come from? Well, it comes from pathogens. Well, what are pathogens? Well, pathogens are produced by bacteria, and we're going to talk a lot about bacteria and funguses and things like that on this podcast, as you'll see. But again, pathogens come from bacteria, and pathogens produce disease. Okay, so that's a pretty important concept that a lot of us don't make right now. Well, if you're a plant, again, and you're in the dark, if you're sort of in this sugar switch, you're going to be super susceptible to disease because you don't have much of an immune system. It's everything that you can do to stay alive. Okay, so it's not a favorable place. But again, we are a product of our diet and our environment. So we can create a diet and environment that's favorable to disease, and that's exactly what we've done for ourselves right now. So you can go conspiratorial and say that was created for us. But we certainly have a way out of it. The way out of it is just knowledge. But we have created a diet and environment for ourselves that's a worst possible thing for our human health almost. And just as easily, we can create a diet and environment that's more favorable to us flourishing, to us to being a plant, in the light with all the sunshine and nutrients that we possibly could need. Okay, so concept 1, if you will, is kind of mitochondria and how they work, and that they run on these 3 different types of fuel substrates. And that, over here on glucose, you're a plant, in the dark with no food. You're super susceptible to disease. In the mid state, that's kind of where we want to be. And we don't even know about that 3rd state yet, or if we can get there. So we'll be talking a lot about that down the road. But let's just talk about the first 2 for now, as I've said. So I want to introduce another concept to you guys. And so mitochondria, concept 1. Concept 2 is something called fasting and fed. Now, this is a super important concept. This has to do with your metabolism, so your energy balance and kind of how you burn energy. But this is a super important concept that really should be taught in grade school. If you've ever wondered, gosh, I can't lose weight. Why can I not lose weight? Well, this will explain some things to you potentially when we kind of walk through this concept of fasting fed. But I also want you to think of it in the context of what we just discussed, the mitochondria, and how our behavior influences our switching between plant in the dark mode and plant in the light mode. Okay? So pretty important concepts, and pretty important concepts that we all should know. All right, so after you eat a meal, right after you eat a meal, your body is extremely concerned with the dietary fats that you just consumed. Your body is going to spend 5 hours dealing with the dietary fats. So it's going to be looking at your adipose, so your fat tissues. It's going to be looking at your white adipose tissue and your brown adipose tissue. Are your fats properly modeled? If the answer is no, then it's absolutely going to be looking at what you just consumed. It's going to be reshaping those dietary fats. It's going to be pulling in triglycerides from your adipose tissue, rebuilding those, and then shipping those back out into your fat tissue. That's going to happen for 5 hours after you eat a meal. Incidentally, just as a side concept here, fat is what signals us to eat, or fat, other things do too. Certainly your nutrient needs signal you to eat, but your fat can signal you to eat when it is not properly modeled. So if you don't have the proper ratios of saturated and monounsaturated fats, and then omega-3 and omega-6 fatty acids, your fat wants to have that, and so it's going to signal you in the only way that it can to get that, and that's through ghrelin, which will make you hungry. So fat will signal you to eat if the fat's not properly modeled, and it has nothing to do with how much you weigh. Okay? You can weigh 1,000 pounds, and if your fat's not properly modeled, you're going to want to eat because your fat's not properly modeled. So it's just that simple. But anyway, 5 hours after you eat a meal, you will be storing fats. You will not burn any fats. You might in a micro, in an exercise thing or something, but generally your body will not burn any fats at all for 5 hours. After 5 hours, again, you go to the mitochondria, there's a cellular switch, and it's called AMPK. And that switch will literally flick between our water substrate glucose and our dietary fat substrate, and we'll go to a more efficient mode. We'll go into something called fasting. Now in fasting, your body burns fat, okay? So all the fat that you just stored, you'll start burning, and you'll start burning that in sort of fuel order, and you'll burn your most critical fat last. But again, burning fat, you're 50 times more efficient, 50 times more conscious. Your engine runs 50 times better, however you want to think about it, but 50 is a good number. So when we eat, we are in fed for 5 hours. After 5 hours, we flip to fasting where we want to be. Question: if you eat breakfast, drink that Coke before lunch, eat lunch, get a little tired in the afternoon, so you slam that energy drink at 4 o'clock, go home and eat dinner at 7, then eat that cookie right before bed. Do you ever get to a fasting state? No. You're a plant in the dark with no water and no light. Let that sink in. If you drink Coke all the time, or Pepsi all the time, or even Diet Coke, it's not so much a function of calories. It's a function of your body knowing that you just put something in your stomach, and now I'm going to have to deal with it. 50 calories, is about all it takes to flip you to fed. Any kind of sugar, any kind of dietary sugar, whoop, flips you right there, and it actually will keep you there longer. Something like high fructose corn syrup. High fructose corn syrup is everywhere in our diet. It forces you into fed, so it forces you into fat storage, and you'll store fats for a longer amount of time. You won't flip to fasting as quick as you normally would. So it's super important what we put in our bodies, but it's super important to understand these concepts because then we have control. We actually have some control of our health. So again, if you eat all the time, you're a plant in the dark with no water. You're going to be you're creating an environment for sickness, let's just say. So you're going to be way more susceptible to disease just by virtue of your behavior. If we eat one big meal a day, to me, it looks like we're designed to kind of eat one big meal a day. And again, if you read about fasting and you read about sort of people's experience with fasting, if you don't eat, and I'm not recommending that you don't eat for 24 or 48 hours, I'm recommending that you just eat one meal a day and don't eat in between, or worst case, eat 2 meals a day, but try to do that between like noon and 6, okay? And so that way you give your body a lot of time to get into fasting, and your body begins to heal itself. I mean, your body begins to recover from being a plant in the dark with no water. Okay, so everybody got those concepts, hopefully. So fasting and fed, super duper concepts, and again, directly related to mitochondrial function. So the performance of your engine, if you will. Okay, now we're gonna have some fun because we're gonna talk about old Holly the bear. And Holly the bear is kind of fun to talk about because Holly understands fasting and fed way better than Chip ever did, or humans seem to right now. So let's just talk Holly through and talk Holly's behavior through. So Holly actually is a real bear. She's been studied. I think she's an Alaskan bear. She may be a Kodiak bear, but yeah, she's up there. She's a grizzly bear. But Holly comes out of her cave, in the spring, and she's a hungry bear, right? She's a skinny, hungry bear. But she does something right off the bat. She understands that she has to model her fat. So she has to first begin to build brown adipose tissue, and that has to be properly modeled, and then build white adipose tissue on top of that for winter. She starts eating a lot of omega-3 fatty acids, so she eats a lot of salmon, fish, a lot of things that promote leanness and muscular, basically physique. By the end of the summer, Holly is a buff bear. There are no fat summer bears. Every summer bear is built, I want to go lift weights with that bear, right? So that is a built buff bear. So Holly, by the end of the summer, because she's properly modeled her fat and she understands what to eat, she is a buff, muscular bear. She changes her behavior in the fall. She understands fasting and fed. She starts eating all the time. What happens when you eat all the time? Your body packs on the fat, and she starts packing on the fat. So by the end of the fall, Holly is one big obese bear. If Holly and I went to the cardiologist would go, whoa, Holly's got issues. We need to get her on, something right away. She's at risk for diabetes. She's going to have a heart attack. She's an obese bear. And guess what? If Holly stayed that way for, a couple of years, 3 or 4 years, Holly would have all those things. She would get metabolic syndrome, again, because your body's just not built to do that. But Holly doesn't. Holly goes into the cave and Holly fasts. Holly doesn't eat for 5 minutes, more than that, 5 hours, even more than that, 5 months. So Holly doesn't eat for, 4 to 5 months, and she runs on nothing but dietary fats that she's built up over the course of the fall. If she's modeled her brown adipose tissue properly over the course of the spring and summer, she'll have a wonderful hibernation. She'll be able to sleep, and she'll be able to control her body temperature. If she ate too much saturated fat or too many omega-6 fatty acids during the summer and spring, she will have a horrible, horrible hibernation. She won't be able to control her sleep-wake. She won't be able to thermoregulate, and that's not a good thing for a bear. So a lot we can learn from just observation and logic from a bear, but those are all hard research studies. Okay, so just to kind of recap on the modes of operation of a mitochondria. So we kind of have a plant in the dark mode, right? So that's when we're running on a water substrate. So we do that right after we eat a meal, and we'll do that for 5 hours after we eat a meal. We do that in a micro fashion with cancers. So again, cancers are generally running on this sugar processing. They don't beta oxidize, which is kind of your middle switch. We do this in muscles. So you do this right off the bat in muscles. This is something called anaerobic. Anaerobic exercise would be glucose burning, so would be no oxygen, and would be the least, honestly, efficient way that we can go. Now, if you're trying to lift something heavy real quick, again, this is the way our muscles are built, and so they'll go to this, right off to provide a lot of quick energy. But if you're doing something like running a marathon, you're going to go to the middle switch, which is kind of what should be our normal operation. It's not, for a lot of us due to our behavior, but it should be our normal operation. So what that is when we're processing fats, within our mitochondria. We need oxygen to do that. So that it's the process there is called beta oxidation. So that is actually what the mitochondria are doing, and they need oxygen. Way 50 times more efficient than glucose. there is a cellular switch called AMPK that does get thrown. And so there is a kind of a known way to flip that switch and unflip that switch. And again, that's a very useful piece of information. A lot of things in nature, will sort of push us to normal operation and away from plant in the dark mode. And those are good things to know about, certainly, if you've been kind of running in the dark for a long time, let's say. And then the last way that you can run a mitochondria is really I'll call it plant operation. But it is, the most efficient way. We would call it photosynthesis, again, but you do it. It certainly is more efficient than fat processing. It does still take resources, though. We have this nice symbiotic relationship between carbon dioxide and oxygen. So again, we, humans, mammals, animals, fix oxygen. So we fix oxygen inside of us. That breaks down, but that provides food for plants. And so we fix oxygen and provide carbon dioxide. Plants fix carbon dioxide and provide oxygen. So that's a very nice symbiotic relationship that we have with plants. And again, arguably, it kind of goes on inside of you as well. Okay, so concept number 2, we've just talked through kind of the fasting and fed, let's call it concept, but how our behavior really determines a lot of our human function. The last concept that I want to walk you through is the endocannabinoid system. The endocannabinoid system, first of all, just for background and real quick, doesn't really have much to do at all with medical marijuana or cannabis. So most people go there right off. You say endocannabinoid, they're like, yeah, what kind of cannabis are you talking about? It's like, no. The analogy would be you have something called an endorphin system, right? And morphine was used to discover it. So that is the same analogy. We have an endocannabinoid system. Cannabis was used to discover it, and so it's named after it. So what is this endocannabinoid system? If you're on YouTube, you're going, oh my God, that's the most complicated slide I've ever seen. And it is a very complicated slide, but it's useful in talking you through this. The slide is actually from a Damasio. So Damasio, probably the lead researcher on the endocannabinoid system. He's an Italian fella. Again, if you ever try to listen to one of his lectures, you're gonna have to learn Italian. But he is prolific and he is broad. He does a lot of very, very good studies. But this last study that he did, or I guess a 2019 study that he did, what this says is that as we eat 8 dietary fats, and you can think of these as the fats that you stick on a triglyceride, but as you eat these 8 dietary fats, as soon as they hit our intestinal lumen, they combine with the most basic amino acid we have, ethanol amine, to form endocannabinoids. The formation of those endocannabinoids is communicated to our hypothalamus hippocampus. If we go back to the car analogy, that would be the computer in our vehicle. So we're getting communicated in a major way to our computer. Our computer then makes a determination, or our hypothalamus hippocampus makes a determination to our nutritional state. So are we getting the dietary fats that we need or not? If we're not, or if we're partly deficient, then the hypothalamus hippocampus will use the endocannabinoid system to allow us to develop a gut microbiome. The purpose of that biome is to allow bacteria to develop. Those bacteria will produce useful proteins that offset our dietary deficiencies. Isn't that cool? That is a very and highly evolved system of function that humans have. And in this way, we're able to eat, all different kinds of things. What's important in our diet? Really just 2 things, dietary fats and chlorophyll. We certainly need calories on top of that, but we run on dietary fats and we make up based on the dietary fats that we input. Right now, what we're doing is we're eating only the inflammatory fats, as I mentioned before. So saturated in omega-6 are inflammatory, monounsaturated in omega-3 are anti-inflammatory. If you do that and add sugar, it's the worst situation for your gut biome because you have to build or allow bacteria to develop to offset and build all of the anti-inflammatory immune mediators that we need. And when that happens, the bacteria become out of control, or they could become out of control. If you throw a bunch of sugar on top of there, or glucose, that allows the bad bacteria a substrate to develop in. They love sugar. If I want to grow bacteria in my lab, I'm going to grow it in agar, which is sugar. I'm not going to grow it in fiber. And fiber is what the good bacteria inside of you like, okay? So dietary fiber, chlorophyll, and dietary fats are our manna. And again, that is directly goes to what we need to feed our mitochondria and fuel this master regulatory system called the endocannabinoid system. You guys seeing why this is a pretty important basis and why we need to lay down a lot of this information. So that's about all I've got for you guys today. Again, I hope that you find this useful. We're going to refer back to this a lot, these three concepts really of how you work. So what is your engine? Where do you hold your intelligence, your consciousness? And that would be your mitochondria. Again, what is fasting and fed? So, how can you control inputs to these mitochondria? And then the third concept is the endocannabinoid system. So basically, how do you control your body? How does your body control itself and function? And again, it turns out we work a lot like a car. So we fully understand that in a car, we have a computer. That computer uses our electronics, a sensor array to look at the engine status, carburetor status, everything in that vehicle. And then it uses that same array to be able to make changes. So if we need to adjust a fine little thing in our carburetor or in our engine, the computer in our vehicle will do that. Well, it turns out we work in a very similar way. So hypothalamus hippocampus is the computer in our vehicle, and the endocannabinoid system is our sensor array and mechanism of change. So really cool stuff, right? And the best news about this, again, I can teach you to be a good mechanic. If I have a good mechanic, there's really nothing that's wrong with my vehicle, that mechanic can't address or fix. These concepts can be taught. Anyone can be taught to be a good mechanic. You don't need a PhD. I don't have one. You don't need an MD. I don't have one. I taught myself these concepts. And again, I hold the philosopher's stone. I am required to teach them to you. Thank you very much. I enjoyed chatting with you guys today. I look forward to our other podcasts. Again, we should have some exciting ones come up, so watch for the advertising around those. See you guys. Have a good day and stay healthy.